When you read about these amazing accomplishments in machine learning, you hear about these huge machines that enable it. Often TPU clusters, not even GPU, and they're massive, like thousands of cards that are working together. And yeah, most people come to me and ask me, what kind of hardware do I need to buy? What do I need to upgrade from my work laptop? And in this video, I want to dive into whether you can train with a laptop or not. Most people don't use desktops like this one every day. Most people use a laptop, right? So, I don't know. Like, desktop computers are really clunky and laptops are really aerodynamic. So there are pros and cons to using both. These clunky machines are usually only used by scientists or by people doing video processing, and of course people who like gaming. Whereas with a laptop you can just sit on the couch. So yeah, and work often gives you a laptop. Even if you're a PhD student, often your university will give you some kind of laptop. A lot of people have approached me, especially early career researchers and people doing their PhDs and masters. What kind of computer do they need? Can they get the new Mac M1? Because it sounds really good, but it's new. Can you trust it? Others have asked me, like, for budget, and they were budgeting $3,000 computers. So yeah, let's have a look, because that might not be necessary. Historically, Apples were marketed towards creatives, people working with Photoshop, and the iPads, of course, with Procreate, the beautiful comics that come out of it. I love it. But now Apple really has stepped up their game. Everyone was a bit cautious when they were moving away from Intel, because such a major change means that the entire chipset is changing, and that means all the software people have to work with this new hardware in everything, and that makes everything really complicated. However, with all the benchmarks that are coming out and marketing and everything, the M1 seems to be really interesting. And even Google have worked on a specific TensorFlow implementation for deep learning, especially for M1 architectures. And they are like out of beta already. And this is huge. Like, seeing something like that on a chip that has a specific neural engine is huge. Apple are really investing in this, and it is being adopted by TensorFlow. Personally, I've never really owned a Mac because they're quite expensive and I don't have that kind of money. Also, the open source Androids are just really nice in my opinion, and you can do a lot of it which you had to jailbreak your Apple for. So I never really made the jump. But also, all my Mac owning friends had to have external GPUs for doing machine learning on their laptops. And that kind of seemed a bit silly to me when I can just have something like that for a smaller price and do some really heavy lifting. So yeah, the M1 really changes the game. But this isn't just about Macs. Machine learning isn't just deep learning, isn't just neural networks that need these GPUs to train. You can learn a lot of machine learning models on a CPU, on a very old Mac, the 2016 MacBook that a lot of people love, and my Windows computer. They are adequate for a lot of machine learning modeling and for most data science. You can do most of the visualizations, and if it's not enough anymore, you can always go to a cloud instance and pay maybe a couple of dollars. And in a future video, I'll show you how to get some for free as well. But that's a future video, so you know what to do. But yeah, a few dollars to upgrade to huge infrastructures hosted by Google, hosted by Amazon, and you don't need to carry a 5-kilogram laptop with you. Let's have a quick chat about computers and computer hardware. Because to do calculations and to have a proper computer, you essentially need 3 things. First, there's the CPU. And the CPU is kind of the brain of the computer. And it is good for complex computation and calculation. So everything that you do normally, run your programs, That's what the CPU is doing. And it closely interacts with a special kind of storage, with a memory it's called, which is called RAM. So this RAM is kind of like the short-term memory that humans have in their brains. This is opposed to hard drives. They're really good for long-term storage. You install all your programs on it and you have your pictures saved on it, but they're slower to access, but very good for long-term. And then we're getting to the interesting bit, the graphical processing unit, or short GPU. So we have the CPU, that is the complex one, and the GPU, which is the graphical one. The GPU developed over time. It was made to make games more realistic, to have these 3D renderings of whatever you're playing, whether it's a horror game, a shooter game, or some 3D simulation, or Sims, obviously, and to make those look better, to make your 3D models look crisp and look realistic and nice, and to be able to look at more things. People develop GPUs. And 3D graphics are essentially just linear algebra. They're matrix calculations where everything is in space. And that means that people slowly figured out that you can also do scientific calculations. The classic ones where you do matrix calculations, you have to invert a big matrix or something like that on your GPU. And then suddenly someone figured out, well, a neural network is essentially just a big linear algebra system, and you can also solve that on a GPU. And as an aside, people always ask, so why don't you do all calculations on a GPU? GPUs are good at this one thing. They are good at exactly this, calculating matrices. They're super fast at that, and they're highly specialized for that. You can see right here that the architecture of CPUs and GPUs is very, very different, because CPUs are for complex tasks and GPUs are for linear algebra. And they're really good at throwing a bunch of matrices together. Now, these GPUs have a special memory. It's also called RAM, but we call it video RAM, so VRAM. And because this one has to be even faster, it's much more expensive and usually baked into the card. So a GPU card usually has VRAM on it, and that usually means that the VRAM is also much smaller. So the card that I have in here has 8 GB of VRAM, whereas my normal RAM in this computer is 32 GB because I didn't want more. Like the clusters that I'm calculating on have 200, 500 GB of RAM, and the VRAM in the cards is 8 GB to 12 GB. Many work-issued laptops usually only have a CPU and something called integrated graphics, and that means you can often watch Netflix and YouTube on them, but if you start up a 3D game that is maybe 10 years old even, they will buckle under the load. So that means these kind of tasks that do like graphics and matrix calculations are really not good. Mostly these are applications, or well, these are laptops that are made for Excel and for having a browser open, for writing Word documents, and not for these heavy calculations. So the laptop that I just threw over there, that's a bigger one. It actually has a dedicated GPU, and I can do deep learning on it. There's another thing that totally complicates this kind of buying of hardware. I already talked about different vendors like Intel and ARM in Macs. Now, if you want to do classic deep learning on a graphics card, so on a GPU, that means you have to be careful that you get the right one, because right now it's only possible to do this kind of training on Nvidia cards. The card that I have in here doesn't do that. They are working on it, there are some changes, but it's still really hard, and the easy way is to use an Nvidia card. And I hope you're still here, because this was a lot. And that is also the point. It's really hard to see that you have the right configuration, and if you want to do machine learning, you have to get the right provider, and it's a mess. That's why I wouldn't really do deep learning on a laptop. So, do you need a GPU? Probably not. I don't think it's necessary, especially for people starting in machine learning. and even some of the more advanced people. Most of the more advanced people. Most people are building classical machine learning models, not neural networks. And you should probably start with some scikit-learn models as well. And those are mostly decided by the CPU. Now, interestingly, I can show you that I can run a scikit-learn model on my phone. And it's good enough, it works really well. The CPU decides how fast you train your model. But honestly, most of the time it doesn't matter, because machine learning models train relatively fast. CPUs are still really, really fast calculation machines. It is, however, constrained by RAM, because most models cannot train iteratively. So you can't feed them piece of your data, another piece of your data. Most classic machine learning models have to fit the entire model and the entire data into your RAM so you can train it once and then get your results. So that really means that seeing that you have a good amount of RAM in your laptop will mean that you can train larger models. In my experience, for classic machine learning, you should prioritize RAM in your laptop. You don't necessarily need to get the gold standard CPU, because like you get diminishing returns. The CPU, like a mid-tier, good enough CPU with a couple of threads, perfect. But don't go out and buy like a $10,000 CPU because you think it'll get your model to converge faster. Usually, if you need to make those kind of optimizations, you have a problem at a different part in your machine learning journey. So yeah, buying your way out, especially with a CPU, usually not that important. Especially in office laptops, if you have troubles opening some Excel files because your RAM is maybe 4 gigabytes, you will have problems training a machine learning model. Then your computer is a little bit small for these kind of tasks of numerical computation, and you should definitely work something out with your job to get a beefier machine. However, and that's a really cool thing, you should be able to validate your code on any old machine. So if you plan to do something in the cloud, but you want to run it on your laptop first, that means you can run your code and until it crashes because you're running out of memory, which, I mean, it happens. It doesn't matter. Like, your laptop is going to be fine from it. But yeah, then you know that your code runs and you can submit it to a cloud job. And that's one way that you can stay within a budget on your laptop, but yeah, still utilize state-of-the-art machine learning jobs. If you do have a GPU and you want to train some of the classical models a bit more advanced, then you can use something like Nvidia RAPIDS cuML, which uses most of the like classic machine learning models, but has optimized them for training with GPUs. Now, there are some trade-offs, but they can often run faster, which is really cool. Like, if you have a GPU, cuML is, and like the whole rapid stack is definitely something to try, but you run in the same limitations that if you don't have enough RAM, or in this case VRAM, you may not be able to train as big of a model as you want to. Is that all you should consider? No. I hate running deep learning models on my desktop. I've done it before, I've done it at work, and it's dreadful because usually deep learning models go to the edge of your computer's performance, and that means your computer is completely frozen up for the time of training. And oftentimes they train hours to weeks. So submitting it to a dedicated machine is so much better. And a lot of times I recommend doing that. In fact, one of my older PCs, I was training a model on it, and afterwards I could hear the graphic card, like, I could hear this super high-pitched noise, and yeah, I'm not a fan. Like, I'm not saying I broke it, but there was definitely something going on after I did some deep learning on a local machine. So yeah, use a cloud instead. Cloud instances are really cheap these days. You also have to consider that these kind of computers, when they're running at 100%, have significant power draw. So right now, power isn't cheap, and that means you're paying a significant premium just for running it on your local machine, where you could just submit it into the cloud, seriously. And where there's power, there's heat. So if you have a laptop, like the laptop with a dedicated GPU, it can run really hot. And these kind of gaming laptops are notorious for running hot when you're gaming on them. It's even worse if you're like continuously running a deep learning job on it for maybe a day. So even if you have the M1 machine, or if you get a nice GPU laptop, maybe just use it for prototyping, like building a small scale version of the thing that you do want to train, but I wouldn't really run it continuously. I don't think it's good for hardware. It's not good for your electricity bill. It might not be great just for you working on anything else. So can you train machine learning on a laptop? Yes. It might not be those state-of-the-art deep neural networks, but you can definitely run scikit-learn on anything from a phone to your office laptop and try out how it works. Deep learning is a bit more tricky, but we have TensorFlow for M1s, and you can definitely try it on the new MacBooks. Now, I know there are M1s in the new iMacs as well, which is making it really interesting. I know that's not a laptop, but this means that on the M1 iMacs, you will be able to train state-of-the-art deep learning models. On the smaller MacBooks, one of the limitations is they have very little RAM. And especially when you're doing image processing, that's not an option. So you should probably stay away from it, unless you really, really want a Mac and you really want to try it. But the iMacs with a higher configuration, that might be a valid choice. So for machine learning for science, I recommend getting like a mid-tier laptop, maybe with a GPU if you really want to, but definitely with a nice CPU and enough RAM. Maybe have a look if you can upgrade it. Sometimes you can add another RAM module in there, and that should give you like a beefy machine where you can do a lot of experimentation on it. And eventually, if you want to do deep learning, like I said, there are free options. You can go to the cloud, and it's not as expensive as you would think. I've run a lot of cloud jobs for hackathons, and the most expensive one cost me like 20 quid. So it's not that bad, especially if you win. But yeah, so where do you train your models? Do you have a laptop? Do you have a desktop? Do you train your jobs in the cloud? If you have hardware questions, leave them in the comments. I will be able to jump in, and some others might be as well. It's a really nice space, and yeah, thanks for listening. I hope this helps.